Welcome to the theory of rotational geodynamics and hydraulic confinement, a new vision of Earth. We unify classical physics, fluid mechanics, and astrophysics to explain the formation and structures of our planet. We question the traditional model of plate tectonics, which presents fundamental inconsistencies. How can thin oceanic plates push thick continents? This challenges physics and the resistance of materials. Newton's third law and materials mechanics do not support this premise. The traditional model ignores 98% of the deep Earth, a critical gap. 4.5 billion years ago, the Earth was a sphere of liquid and viscous lava, our primordial engine. Differential rotation generated higher linear velocity at the equator, creating shear force in the magma. This resulted in the vortex panning effect with large circulation cells organizing the lava ocean. Centrifugation collected minerals, light cream, silicon, and granite towards the cold center. Heavy elements such as iron and gold are concentrated in the zones of maximum compression. The light matter crystallized rapidly upon contact with the cold of space, forming the first craton. Force on the inclined axis drew diagonals on the terrestrial sphere, forming these structures, such as the Amazonian, Snow Francisca, Congo, Baltic, and Laurentia, are examples of these ancient formations. We challenge the idea of slow and linear deposition of rock layers. The Earth is more dynamic. The Cratons visible in the Canadian, European, and Brazilian shields. They record seasonal or decadal events. The Earth's rotation lost speed in a step-like pattern, influenced by the Moon and the Sun. The first locking between 1.8 and 1.4 billion years ago stabilized the speed at 19.5 hours. This allowed the welding of the Cratons into the supercontinent Columbia or New. The second breaking step from 900 to 600 million years ago slowed the day to 21 and 22 hours. This abrupt breaking generated a monumental torque on the deep keels of Cratons. The Amazonian Craton slipped and rotated to fit with the Snow Francisco and Congo Craton. This readjustment from below consolidates the supercontinent Gondwana, shaping ancient geographies. This occurs in the fractured zone of the oceanic margin, explaining the uplift of the Andes. Subduction is secondary. Hydraulic confinement is the primary driving force. The Earth is a closed and predictable thermal machine with a logistical end to its system. This evidence reinforces the rock and bowl effect and the rhythmic nature of Earth formation. The theory of rotational geodynamics and hydraulic confinement offers a new and coherent explanation. We invite you to explore this perspective and deepen your understanding of our planet. Subscribe to our channel and comment on your understanding about Cratons, and help us propagate their importance.